Alright, I'm back with my partner in crime, Minnie Mostly, for another Max Robotics project episode. Check out this aluminum baseplate that we designed for the two-wheeled robot that we shared in the last video. Up until now, we've been iterating on 3D printed baseplates, and we've been limited to the max size of our 3D printer's heat bed. This black one had fixed mounting holes and slots, not a super flexible design. Then we rolled a more configurable version with a grid of half-inch spaced holes for M3 screws. Now we're taking it to the next level with this aluminum version that's 4mm thick and is slightly longer than our 3D printed variants. Shout out to PCBWay for sponsoring this project and making this new baseplate for us. For the longest time, I thought PCBWay only manufactured PCBs, but then I discovered that among several other services they offer, they do machining and metal fabrication. Definitely right up my alley. We already had CAD files for the robot baseplate, so all we had to do was upload them to PCBWay.com. We used their sheet metal service to have it laser cut out of 6061 aluminum, then it was bead blasted for a smooth matte finish, and then finally it was anodized in dark gray. I also uploaded a design file containing the Max Robotics project logo and decorative text so that it could be laser engraved on both sides of the baseplate. The contrast of the anodized finish and the raw aluminum color coming through the laser etching just looks awesome. I intentionally chose a kind of complicated surface finish on this just to see what PCBWay is capable of. Alright, PCBWay stickers.
Whoa!
Awesome.
So shiny. That's sick.
Check that out. Wow. They truly knocked this thing out of the park. It kind of blows my mind that you can have something this high quality custom made and sent to your door. Just upload your design files and go. Amazing. Okay, let's move everything over to the new baseplate. Alright, now that all the parts are taken off, let's start putting this thing together. Let's put the motors and wheels on first. The brackets that came with these motors aren't really my favorite. The screws end up kind of hidden under the body of the motor. I've been thinking about designing a new bracket with flanges that stick out on either side of the motor body for mounting. With these motor mounts, it's a little tricky getting the nuts threaded on those screws without everything falling apart. And with a little video magic, the other motor's on there too. Now we can put on the rollerball assembly. Alright, this is really coming together. I still can't get over how awesome this baseplate looks. Okay, let's mount the controller box. It's kind of sad to cover the center logo, but luckily it's visible on the bottom if you flip it over. I ended up moving the control box around a few times and ultimately settled on attaching it with 2 screws instead of 4. I forgot that the motor bodies get in the way and you end up with screws being covered that you can't access without taking the motors off. I think we should probably adjust the heat set insert hole pattern on the bottom of the control box to allow it to clear the motor bodies. Not today though. Be sure to subscribe if you're interested in seeing more updates. The reason we made the baseplate a little longer is to make room for a battery holder mount. I whipped up a quick prototype that's essentially 2 raised bars that the battery can sit between, and then we can loop some Velcro around it to tighten it around the battery. Not bad. I think I might opt to make the holder bars a little smaller, but this is a totally functional first attempt. I'm also going to throw a zip tie on there to secure the motor wires underneath. Eventually I think we're probably going to shorten these wires and solder them directly to the interface boards, rather than having them plug into header pins. I'm just not quite ready to commit to doing that yet though. Alright, now we can hook up our kind of ridiculous wire bundle for the motors. Let's get a look at this thing. Man, I'm in love with this baseplate. It looks so awesome. It has no flex in it, which is great. That's something that really bugged me about the 3D printed plate that we were using before. The standardized grid of holes is super nice. No more having to roll different versions for mounting changes or adding accessories. The motor access slots are also perfectly aligned with the interface boards below. You know what? This thing is just too pretty now to have this ugly bundle of motor wires hanging off like this. I bought 2 rolls of 16 gauge silicone wire that I've been meaning to use to make some custom length power cables. I soldered these up real quick and crimped some 4-pin connectors for the motor encoders. I love these XT30 connectors. The solder cups face out to the sides to make it easy to get in there with the wires. And the connector housing is marked for both positive and negative, making them pretty idiot-proof to hook up. Oh yeah, this is way more clean now. Alright, here's the full evolution of the base plate. Version 1 is this black one with fixed holes and slots for Velcro straps. Version 2 is this orange and black one that introduces the standardized grid of holes. Then finally we have this glorious aluminum plate. We widen the holes very slightly compared to the orange V2 plate to make it easier to put screws through it. The extra length of the plate gives us mounting options for the battery and maybe other accessories in the future. This new base plate is an awesome upgrade to an already epic build. A big thanks to PCBWay for sponsoring the project. We hope you enjoyed this one. Drop a comment below and let us know how we did. And if you want to see more, consider subscribing. Alright, Mini Mostly, take it away.
Thanks for watching, and we'll catch you in the next one.